Okay, I hope you're well wherever you are, and I welcome you to today's discussion about the soil structure and soil texture. So we'll begin looking at soil texture. So with soil texture, it refers to the relative proportions of the different mineral particles, be it sand, silt, and clay, which make up the soil. Soil texture is about the proportion of the different sizes of the particles that make up that particular soil. So these particles, whose size is making us to refer to the texture of the soil, they result from the weathering or the breaking down of rocks and other minerals over time. And therefore these particles have a direct influence on how, when you touch the soil, how it feels, the ability of that soil to hold water, and by extension, the ability of that soil to support plant growth. So we've seen that soil texture is about the size of the different particles. So what are these different types of soil particles? Okay, so the first type is sand. So sand, in terms of size, they ranged from about 0.05 millimeters to about 2 millimeters in diameter. They typically are round or irregular in shape. In terms of porosity, they have porosities, the size of the pores. So they have high porosity, which means they have large spaces between individual particles. So through those large spaces, water can move very fast. Water can drain very fast. And because of the large spaces, therefore the sand particles will have large or plenty. They have many air pockets. So because of the high porosity, their ability to retain water is poor. Why? Because the water is flowing through very quickly, because there are large spaces between one particle to another. Then given that water can move fast through these particles, it means that moving water equally can wash away the nutrients. So then the sand particles have very low ability to retain nutrients. They have very low ability to retain nutrients. So these sand particles are found in beaches, in deserts. Okay? So because of the constant weathering of the rocks that happens in the beaches, that happens in deserts, then we have so much of the sand particles found in these places. The crops which grow, which can thrive on these sand particles, they include carrots, potatoes. But now what has to happen? There has to be frequent watering, because remember, the sand particles have very large pores. So meaning the water can pass through very fast. The nutrients can also be washed through with the water that is passing. So it means when you've planted anything on these sand particles, then you have to keep watering and applying fertilizer frequently. If you want to improve the sand particles, then you need to add organic matter. Organic matter, we are talking of things like the compost. So when you add organic matter, it helps to retain moisture. It helps to retain nutrients. Then when you've planted things on sand particles, you have to ensure that you use mulching techniques. so that you can reduce the rate of evaporation. The second type of soil particle is silt. So silt has medium-sized particles. Their shapes are relatively smaller and smoother than sand. The texture is soft and silky. Then the porosity, the number of pores between the various particles of silt, they are small, they are moderate, so they are smaller compared to the pores you find in sand. So because the pores are small, they therefore end up reducing the airspace. Okay? So they reduce the airspace. The amount of air you find in silt is smaller compared to the amount of air you find in sand. Okay? The water retention is slightly higher. Okay? So silt has a higher ability to retain water. The nutrient retention is equally higher compared to sand. Okay? It's higher compared to sand. So where do we find these silt particles largely? We find them in the river valleys or in the flood plains. So silt is often deposited by flowing water. So it's in the river valleys that we'll find water will have deposited silt there because the water is flowing down a river. In a flood plains, talk of the Kano plains, that's now where you find silt has been deposited by the water which was flowing through those plains. So the excellent crops for silt-rich soils include wheat, include rice and maize. So that's why you find rice and wheat being grown in areas like Kano, in areas that rice is grown in areas that have a lot of water. The water is flooded in that particular area. As the water passes, it deposits silt. Then rice does excellently on the silt. So if you want to improve the silt particles, what do? You plant cover crops so that you can prevent erosion. Remember, silt is deposited by moving water. So you need something to be growing on that soil so that as the water moves, it does not move with the soil particles. So you need to have cover crops to trap soil even as the water moves. The other type of soil particle is clay. Clay has among the smallest particles in size. Okay. Their porosity is low. They have tiny spaces between the soil particles. So because of those tiny spaces, then it means the speed with which water moves through clay particles is lower. So water will move at a lower speed. So the ability of clay now to retain water is very high because the pores, the spaces between the soil particles are very tiny. So water cannot pass through those spaces very fast. So because of that high water retention ability, then it means most of the clay particles, the clay soil, will be associated with waterlogging. The water logs in this soil. Maji hayapiti haraka. Sasa inasimama kwa huu udongo kwa muda mrefu. Okay? The nutrient retention is equally high. Remember, the water is not passing through fast. So the nutrients cannot be washed away because the water is equally not flowing through fast. Okay. So Crops that will do well in these clay soils are things like rice and cotton. Okay, but most plants will struggle in this type of soils because of the poor drainage. Okay, because of the poor drainage. So the best way to improve clay soils is to add the sand particles. When you've added the sand particles, you will now help to break down those compacted soil particles. And the sand will now come and increase the porosity. Okay, it will come and increase the porosity. The fourth type of soil particle is loam. So loam is sort of a mixture. It has a mix of sand, silt, and clay in various proportions. Okay, so you could have, for example, 40% sand, 40% silt, and 20% clay. So in terms of porosity, the pores, ile mashimo iko kwa the loam soil, it is balanced. So meaning within the loam soil there is enough space for air, for aeration, because air needs to pass, but also for water to move freely. So because of the pores being balanced, then the ability of loam soil to retain water is moderate to high. So the ability of it to retain water is, it retains enough, it enables it to retain enough amount of water, enough moisture level for the plant roots. But again, it is not enough, it's not too much to clog. So it just retains the right amount of moisture so that the plant roots can do well. They are not clogged and they are not dry. Its ability to retain nutrients is high. So it holds nutrients well, but it does not bind to them tightly. Remember, the nutrients are in the soil, and the roots of the plants growing in that soil need to pick these nutrients. So if the soil is holding onto those nutrients tightly, then the roots will not be able to pull the nutrients from the soil, and therefore the plant will not be very healthy. So it's supposed to be a balance. So the importance of understanding soil particles, it helps with plant choice. So when you know the type of soil particles that your soil has, it will enable you to choose the correct plant, the plant that you need for that area, the plant that is suited to the soil type that you have. Then after that, the second thing, when you've understood the soil particles, it enables you also to know the type of water management skills you need to employ. So when you've understood the porosity, you've understood the drainage, you will know then, do you need to ensure that if you are dealing with clay particles, you have to find ways of ensuring that water does not clog. If you are dealing with sand particles, then you have to ensure that you continuously supply water. Frequently, you supply water. Then the third reason why understanding soil particles is important is for soil improvement. So when you recognize the strength and weakness of the soil that you have, it will enable you to amend. It will enable you to improve. Okay? So if you are dealing with loam soil, for example, and someone else is dealing with sand, the type of improvement that is needed in these two different types of soil particles is different. So when you've understood the type of soil particle that where you want to grow plants on, then you'll be in a position to know how you can improve that particular soil type. So the common soil common soil textures. So when you are talking of sand particle, then they form the sandy soil. Okay. So when you look through, it's still the same thing, only that it's now sandy soil. The initial description was there for the particles. When you are talking of silt particles, they form silty soil. Okay, so all the other characteristics remain the same. The clay particles will constitute the clay soil. All the other characteristics remain the same. Equally, when you are talking about the loam particles, when now they constitute the type of soil, then it becomes loamy soil. Okay. So all the other characteristics, as I've said, they remain the same. The ones we were giving for the types of the soil particles. But now, why is it important for us to understand soil texture? Why does soil texture matter? So, while through soil texture we've been describing the size of these soil particles, it is among the most critical factors which will influence every aspect of plant growth and soil health. So when you have healthy soil, soil that has enough nutrients and it does not hold to the nutrients, it is having enough aeration. Okay, it does not lose so much water, it does not hold onto water for too long. Then you are talking of now soil that is good. Then such soil can now indicate or support plants that are very healthy. Okay, so the importance of understanding soil texture comes in various ways. So understanding soil texture will have an indication on the water retention and drainage of that particular area. So when you've understood the soil texture that you are dealing with of a particular ecosystem, then you'll be able to know the ability of that ecosystem to retain water. Okay? Then you will also be able to know, now if it is retaining water, how do you deal with the drainage? So if you have, for example, sandy soils, they will drain quickly. So because they drain quickly, the roots of plants growing in sandy soils will not rot. But the water is draining, is passing through very fast. So it means you have to keep watering that sandy soil. The clay soil, it holds water, but as it holds to the water too much, it leads to logging. So once the water is logging that particular soil, that particular ecosystem, then the roots of those plants will suffocate. So when you are dealing with clay soil, you have to find ways of ensuring that the water is moving. Okay? Loamy soil strikes a balance, so it retains just the right amount of moisture. Okay, so whatever is excess will be drained. So in a loamy soil, you don't need to worry so much about the water retention or the drainage. So the second reason is about nutrient availability. Soil texture affects the availability of nutrients to the plants that are growing in that particular soil. So different soil particles will bind to nutrients differently. So because clay particles, for example, have tiny spaces, nutrients will hold also tightly to these clay soils. Okay. So it means the nutrients cannot be washed away in a clay particle. The sandy soils will lose nutrients quickly because the water is washing them away. Water is moving around very fast. But the silty and loamy soils will offer a very good balance. So they hold onto nutrients, but still they release these nutrients to the plants. Unlike the clay particle, which does not lose the nutrients, but it holds onto them very tightly, that at times the plant might not be able to use it. Okay? So the third importance is that soil texture will affect or will impact on the root growth and soil aeration. So sandy soils have large pores, so which means the roots will spread through the sandy soil easily. As these roots spread through easily, they also access air because the sandy soil is porous. Okay, so there's a lot of air that is present in the sandy soil. Clay soils, they are compact, so it makes it difficult for the roots to penetrate. And as the roots cannot penetrate because of the small pore sizes, it means also the aeration, the amount of oxygen that is present within a clay soil is very limited. In loamy soils is a perfect example. So there is a mix of enough space, there is a mix of stability. So it means plants that grow in loamy soils will be healthier, their roots will be healthier because they can easily penetrate, they can easily access oxygen, they can access the air that they need. So because of the ease of penetration, then it means plants in loamy soils will be more stable compared to plants that are growing in these other types of soils. The fourth thing that soil texture does is it impacts soil erosion and soil stability. So texture affects how easily soil gets eroded. So because sandy soils are light and loose, hazijashikana inakuwa moja moja, it can be easily blown away by wind. But silty soils erode with water, but they are rich in nutrients. Clay soils will resist erosion. Okay, so clay soils will resist erosion. Silty soils will be eroded, be carried away by water. Sandy soils are light and they are not held, they are not tightly packed. So which means now for them, they can easily be washed away. They can easily be blown away by wind. Soil texture also impacts on the plant suitability and land use. So different plants will prefer different textures. When we were discussing there's different soil particles, we saw which plants grow where. For example, carrots will prefer sandy soils. Rice will prefer clay heavy soils. Well, but most vegetables, other flowers will flourish, will do well in a loamy soil. Now, what is soil structure? That was soil texture. But now what is soil structure? So soil structure refers to the way soil particles in this case is the sand, silt, clay, loam, how these soil particles are arranged and how they bind together. Okay, so how they are arranged and how they bind together. So texture tells us what soil is made of, but structure shows us how what makes up that soil is put together. How the ingredients that make the soil, in this case, how those ingredients fit together, how they are joined together. That describes the structure. So structure comes in different types. One, it could be granular. Okay, some of the soil structure could be the granular soil structure. The other type could be blocky. So that will be made up of block-like aggregates. Okay. The other type could be the platy. So that is made up of plate-like aggregates, the platy structure. And then the other one is the prismatic. With prismatic, you are talking of vertical pillar-like aggregates, but they have a flat top. Okay. So you get to a place where you find vertical pillar-like aggregates of soil, but having a flat top. That type of structure will be prismatic. The other one is the columnar. So columnar, you have vertical pillar-like aggregates, but they have rounded, salt and crusted tops. So the top is not flat, the top is round. And that top as well has salt crusts on it. Then that type of structure becomes columnar. The other type is the massive. These are large, solid, and structureless masses of soil. So you get to some area and all you see, you cannot have a description to the type of aggregate, but all you see is just a large, solid structure. It's large, solid mass of soil. Okay, so such is just a massive structure. The other one is the single grain. So this is made up of the loose particles which don't clump together. And as you will expect, is largely found in sandy soils and in desert environments. So what is it that affects soil structure? What determines soil structure? So soil structure is not static, which means a particular soil might have this structure now, but after some time, it can change. The structure of that soil can change. So a soil structure is not static, it evolves and changes over time. And what determines that evolution and change is a variety of natural and human factors. So some of the key factors include organic matter. So organic matter affects soil structure because organic matter acts like glue. It holds the soil particles together. It helps to improve porosity and helps to increase the water retention capacity of that soil. So this organic matter will come from decomposing plant material, roots, or animal waste within that particular ecosystem. Okay. The other thing that helps to impact on the soil structure is the soil organisms within that soil. So soil organisms within it, animals that live within that soil. We're talking of things like earthworms, the fungi, the bacteria, the microorganisms, and other burrowing organisms. So things like the moles. So what they do, the microorganisms, for example, they break down organic matter. Okay, so when you have microorganisms in a particular soil, they keep breaking down the organic matter. They are the detritivores in that case. So they are the decomposers. So they decompose the organic matter. Then we've seen that once they create that organic matter to decompose, then that organic matter will impact on the soil texture. The burrowing animals will also create channels. Those channels in the soil, because the burrowing animal inasonga inapita chini. So ikipita hivyo inatengeneza mianya, inatengeneza barabara ama mashimo ndani ya hiyo udongo. Hayo mashimo yanasaidia to improve the flow of air and even the drainage within that particular soil. The other thing that impacts soil structure is climate and weather. So how climate and weather affect structure? Rainfall will help in forming aggregates, but equally that rainfall can cause erosion. Okay? So if there is a lot of rainfall in an area, then you can have erosion. The water can move away with the soil, can sweep the soil. Okay? So that will have led to erosion. Another factor that impacts soil structure are the plant roots and vegetation. So when plants are growing, as the roots increase in size, they break down the soil particles, the soil layers. So as those soil layers are broken down, it helps to improve the soil structure, because what was initially compacted, venye mzizi inaendelea kuwa inasonga, ina break, inavunja, then what was just held together as a huge block is now broken by the growing root. As the root increases in size, it ends up breaking up, inavunja those big layers into smaller layers. Okay. Then another thing now, when you have roots for things like grass, they help in stabilizing the soil and therefore preventing erosion. Okay. They will stabilize the soil and prevent erosion. So the roots of vegetation will help to stabilize the soil and prevent erosion. Then the same roots will help in breaking down the compacted layers so that they now become smaller. What was initially too big now becomes smaller. Another factor that affects soil structure is tillage and human activity. So tillage is how you till. When you till land lightly, it can help to loosen the soil. But when you do excessive tilling, it destroys the aggregates. Okay? It destroys the aggregates. Then when you have heavy machinery, pali penye kuna barabara kwa mfano, heavy machinery that is passing a particular place, it compacts, it compresses the soil. Okay? It compresses the soil. As it does that, sababu inafinya, it will reduce the air spaces in that soil. Then by doing that, it ends up now limiting the root growth. Because for the roots to grow, so that the plants can be healthy, the soil must be properly aerated. So hiyo kufinywa inatoa air, inapunguza the air spaces, hapo inafinya the soil particles together. Then because of that, because of even the compacting, now the roots are not able to break through. Okay, so it will limit the ability of the roots to grow. The other factor is mineral content and parent material. So different minerals will bind particles differently. So clay, for example, has natural tendency to form aggregates, while sand does not. Okay. So the type of rock that soil forms from affects the natural structure of that soil and its stability. So if you have clay soil, it will have a different structure. You have sand soil, it will have a different structure. You have loamy soil, it will also have a different structure. Soil pH and chemical composition. So pH is the level of acidity or alkalinity in any particular environment. So the pH will influence the availability of nutrients and the activity of soil organisms. When you have pH that is extremely acidic or extremely alkalinic, then the ability of organisms to survive in that type of soil will be limited. So only some organisms might be able to survive, but not all. Then as we saw, organisms are important in soil texture. So pH largely impacts soil texture by restricting the type of soil organisms that are present. Okay. So why should we bother about soil structure? We saw the importance of soil texture, but why is soil structure of value to us? Why should we bother about it? Why is it that in an ecology unit you are being taken through aspects of soil structure? So you need to understand soil structure because it impacts how water moves and how water is retained in that particular ecosystem. So if the soil is well structured, it will allow water to infiltrate and drain properly. So well structured soil will mean that the ability of water to move, to infiltrate that soil, which is structured properly, will be high. Then it will also drain properly. So we will not have runoff, we will not have erosion because the soil is well structured. But if the soil is poorly structured, think of clay, it will cause waterlogging. Think of sand, it will move through very fast. So if it is poorly structured in a way that the water does not move through fast enough, then it causes logging. Then that one will mean there will be poor aeration in the soil and the roots will rot. But if the soil is so poorly structured that the water drains, water moves through very fast, then the roots of those plants will dry. Okay. So because of the poor structure of the water, the extremes of that, the poor structure of the soil, the extremes of it will all affect the plants that are growing. Root growth and stability. If you have soil that is well structured, it will have enough space for roots to grow. And as the roots grow through the enough space that is provided by the well-structured soil, it will lead for the roots to access nutrients so that the plants benefit. But if the soil is poorly structured, it will compact so easily, and therefore it makes it difficult for the roots to penetrate. Once the roots cannot penetrate properly, then it means the plant will not even be stable. And if the roots cannot penetrate properly, it equally means the same roots cannot even access the nutrients that are present in that soil. The other thing that soil structure does is it affects aeration and gaseous exchange. So when the soil is well structured, it will have the right size of pore spaces. These right sizes of the pore spaces will allow oxygen to reach plant roots and other microbes. So it means because the porosity, the size of the air spaces within the soil is right, so the level of oxygen hapo ndani ya udongo iko sawa. So inamaanisha ile mizizi yenye iko ndani ya udongo inapata oxygen sawa sawa. The microbes and other organisms like earthworms and other bacteria within the soil will also get enough access to oxygen. So which means the roots of the plants will be healthy, and even the soil microorganisms and other organisms like earthworms will also be able to survive. And as they survive, they now help to break down any other organic matter that is present in that particular soil. But if the soil is poorly structured, it will limit airflow. Okay, so you are thinking of, for example, the clay soil. It will limit airflow. Because of that limited airflow, the roots zenye ziko huko ndani, they will suffocate. They will not get enough oxygen supply. Then the plant will die. Then because of the poor aeration, it is possible that harmful gases like CO2 will build up in the soil. Then because of the water presence, and CO2 is there, CO2 and water, it forms a weak carbonic acid. Then how the plant suffers by extinction. Soil structure also impacts the nutrient availability. So if the soil is structured well, the microbial activity within that particular soil will be optimal. The microorganisms will be working properly. And because of that optimal microbial activity, the organic matter within the soil will be broken down. As the organic matter is broken down, the nutrients will now be released. Okay? But if the soil is poorly structured, then nutrients can be locked away. Okay? So you can lock the nutrients away. If the soil is also poorly structured, for the case of sandy soil, the nutrients within the sandy soil can be swept away by the runoff. That's what we call leaching. Okay. Then erosion resistance. Well-structured soil will resist erosion. Okay. But poorly structured soil easily erodes away. So if it resists erosion, there are those soils that have the nutrients. So in a well-structured soil, once the erosion is resisted, then the plants that are present in that soil can now access the nutrients that the soil bears. But if the soil is poorly structured, such that it can be easily eroded, then the nutrients that are part of that soil will equally be lost as the soil is carried away. Okay? So, the very last bit is ecosystem health and diversity. So when you have soil that is very well structured, it will create a diverse microhabitat. So which means in a soil that is properly structured, it will have different organisms. There will be insects, there will be fungi, there will be microorganisms, and even now plants within that particular ecosystem. What that means is that you end up now having a healthy ecosystem, because there are different plants, there are different organisms within that ecosystem. So the more diverse, the more different organisms that are present in an ecosystem, it means that ecosystem can support itself. It's self-sustainable, self-sustaining. Because there will be a niche, there will be a specific role that each of the different living organisms present in that ecosystem are playing. So that will be a healthy ecosystem. And because of the different living organisms that are supported in that ecosystem, it will mean the biodiversity is high. Biodiversity just refers to the different forms of living things that are present. Okay? But when the soil is poorly structured, whatever can be supported on poorly structured soil is very limited. Ile unaweza pata kwa mfano inamea on sandy soil ni kidogo compared to what you can find present in an ecosystem that has loamy soil. So loamy soil has a better structure, but sand soil has a poor structure. So a poor structure reduces the habitat complexity. Not many organisms can grow in a soil that is poorly structured. But soil that is well structured will support diverse organisms. There will be plants, there will be animals, there will be insects, there will be different microorganisms within that particular ecosystem. So that will mean is a higher biodiversity. Okay? So you can read through the notes. I hope I've captured most of the things that you need an explanation for. But in cases you come across something that I've not possibly explained, then feel free to reach out and I'll be happy to explain. Otherwise, thank you very much and I look forward to seeing you. Asante.